Hello, good morning, good afternoon, and good evening, everyone. So we have another 20 minutes presentation about Introduction to DevOps, where we'll be delving into the world of DevOps at little high level. Our presentation will cover everything from its basic definition to its key principles, what benefits it offers, what are the different tools we have to use if we are using DevOps. Let's start by understanding what DevOps is and why it is so crucial in modern software development and operations. So, definition of DevOps, it is a cultural and technical movement that aims to integrate software development with IT operations, emphasizing collaboration, automation, and continuous improvement. But DevOps is just more than this. It is a transformative approach to software development where we collaborate between software development team, IT operations team, then other stakeholders like the QA team, information security team, the program management team, the project management team, the business analysis team. So the basic objective here is to break down the traditional barriers between these teams and foster a culture of collaboration, automation, and continuous improvement. So if we'll align with these critical functions, organizations can achieve faster delivery, higher quality, and greater efficiency in software development. How we'll be learning in subsequent slides. So next comes the key principles of DevOps on what are the principles that underpin the DevOps philosophy. So they are what? Collaboration, automation, continuous integration, continuous delivery deployment, monitoring and feedback. So collaboration is the first principle which bridges the gap between different stakeholders. As I have told earlier, development team, operations team, to be precise, and other teams like the QA team, project management team, the business team, so that they work towards a common objective instead of working in isolation, and might be sometime they work against each other. Then comes automation. What is the use of automation? Automation streamlines processes, reduces errors, and accelerates software delivery. So, what is the need of automation? In our software delivery cycle or software development cycle, we might have many processes which are uh, need to be done by human intervention, and they have to be done repeatedly. For such processes, we have to use tools so that it will bring transparency and it will reduce errors and it will make things faster. Then comes continuous integration, which promotes integration of code change frequently so that bugs could be detected early and we can get faster feedback about our code. Continuous delivery or deployment, it ensures that software is always in a deployable state, ready for release at any time. And finally, monitoring and feedback. It provides valuable insights into system performance and user behavior, driving continuous improvement. Okay. So how these principles affect DevOps, we will learn in subsequent slides. Let's move on. And what are the benefits DevOps offers? Why should organizations use DevOps? The benefits of DevOps are numerous and compelling. So if we are adopting DevOps practices, teams can significantly reduce time to market, enabling them to respond quickly to changing market demands. Increased deployment frequency means the feature and updates reach customers faster, enhancing customer satisfaction and loyalty. How this could happen? So, if you are using DevOps, your software release cycle could be reduced from months to minutes in terms of time taken. So, if you are offering a product to customers and your competition is also offering the same product, you have to come up with better features quickly than your competition. Otherwise, you might lose customer. Now, if you are coming in with the features very early, what will happen? We will reach the customer faster and make the customers happy so that we can gain their loyalty. The customer will not ditch us to competition. And improved collaboration and communication foster a positive work environment and drive innovation. And furthermore, DevOps enable organizations to achieve greater efficiency and cost reduction by automating manual processes and minimizing waste. What is a waste? So waste is a process in our software development cycle which has zero or minimal impact to the software development. So that process could be eliminated so that the software development could be faster. Okay. Then next we'll learn more about the DevOps culture. So DevOps is more cultural than technical. So it the key cornerstones of this culture is breaking down silos, encouraging shared responsibility, fostering a culture of experimentation and learning. So at the heart of DevOps is a cultural shift that emphasizes collaboration, transparency, shared responsibility. Breaking down silos between development, operations, QA, and other stakeholders is essential for a fostering uh, culture of trust and collaboration. So if we encourage teams to take ownership of their work, and empowering them to experiment and learn from failures, organization can create a culture of continuous improvement and innovation. So in DevOps, there are always feedbacks and there is no blame game. So when you are not blamed for any mistake you make, you are assured and you can take risk towards innovation. So that is what DevOps promotes. Building a strong DevOps culture is key to successful adoption and implementation of DevOps practices within an organization. Continuous integration is a practice where developers frequently integrate their code changes into a shared repository, that is a version control system. So continuous integration is also popularly called CI, and this CI process is entirely automated and it often involves running tests to ensure that the new changes the developer has made do not break the existing code base, existing functionalities. There are many CI tools available. The most popular one is Jenkins. Then we have GitLab CI, Travis CI, the Git, GitHub Actions. So these tools help automate the build and test process, providing faster feedback to developers in the early stage of code change. By adopting continuous integrations, teams can patch bugs early in the development cycle, leading to higher code quality and faster delivery of features. After continuous integration, then comes continuous delivery next and continuous deployment next. So continuous delivery is a superset of continuous integration. It extends continuous integration by automating the entire software release process, including deployment to production. With continuous delivery, every code change that passes the CI test is automatically deployed to a production-like environment, for example, staging environment. There are different tools available like Docker, Kubernetes, and Ansible. They enable the automation of infrastructure provisioning and getting the artifact deployed to the desired environment. Continuous deployment reduces the risk associated with manual deployments, shortens the feedback loop, and enables teams to release new features to customers quickly and reliably. Next comes infrastructure as code, or IC. So if I have to run my application, I need infrastructure like server, database, etc. So how will I provision them? I have to provision them by manually installing the software, procuring the hardware and all. So right nowadays the infrastructures are mostly virtual rather than physical. So anyway, we have to procure them. So we need human intervention to procure the infrastructure or to manage them. So this ISE, it is a practice of managing and provisioning the infrastructure through machine readable definition files instead of using human intervention. So there are many tools available like Terraform, AWS, CloudFormation and Ansible. They allow developers to define infrastructure configuration using code. By treating infrastructure as code, teams can version control their infrastructure configuration and apply software development best practices like code review and automated testing. It promotes consistency across environments, improves reproducibility, and reduces the time and effort required to manage software. How? Let's say I have to use similar infrastructure across the development environment, the QA environment, the staging environment, and of course the production environment. I have to take help of the operations team. They have to procure the infrastructure, and while procuring it across environments, there might be some mismatch, but I need consistency. How would I do that? So I'll be using a single infrastructure as code file. I'll give my requirements. This I need this infra in my environment, procure it. So the single file could be used across environments and we can achieve consistency. We can uh, reduce the time and effort required to manage the infrastructure. Then next is the microservices architecture. It is one of the key building blocks. So microservice architecture is an approach to build software application as a collection of small loosely coupled services instead of a single large unit. So in this microservice architecture, each service of the collection is responsible for a specific business function. It can be developed, it can be deployed, it can be scaled, it can be retained, it can be managed independently. It can work in collaboration and in isolation with its sister services. Microservices offer advantage over monolithic architecture, including improved agility, scalability, fault isolation. So in a microservice architecture, if something fails, it will not break the entire suite of application. Rather, it will break only the single service. So that is one of the advantages. But if we are adopting microservice architecture, there would be definite challenge at operational side. How? Because if I am using a monolithic architecture, I have a single application. So managing that at any infrastructure would be easy. Whereas if I am using a suite of services, suite of applications, I have to increase my effort, as well as all these services might be collaborating between each other. So in that case, we should have a better service communication and management. And next is containerization. What is containerization? Containers are very popular nowadays. It is a lightweight mode of virtualization where it enables developers to package the application they are running, and the other dependencies the application needs into a single unit. That unit is called image. An image. An image is stored in an image registry. Then when we have to run the image, we can use any container engine so that it can pull the image and run them into an isolated sandbox called container. So containers run on a machine without disturbing other containers. So containers are called operating system level virtualization. They provide a consistent runtime environment that can run on any infrastructure without modification. Docker is the most popular containerization platform. It allows developers to build, ship, run applications in containers. Now, if we have many containers to manage as an organization, I need something better than the containers. I need a container orchestration tool. So what is the most popular container orchestration tool? Kubernetes. So Kubernetes can help us manage this containerized application, providing features like automated scaling, service discovery, and load balancing. Then next is continuous monitoring. So my application is now running in a container or on any server or on a cloud platform. So what I have to ensure now? I have to ensure that the application is giving me desired results at desired level. For that, I have to continuously watch it. So that is where continuous monitoring comes. It is a very critical aspect of DevOps, which ensures teams have real-time visibility into the health and performance of their system. System in the sense the application as well as the platform on which they are running, the infrastructure. And we have to use tools for continuous monitoring like Prometheus, Grafana, this ELK stack, that is Elasticsearch, Logstash, and Kibana. They provide powerful capabilities for collecting, analyzing, and visualizing metrics and logs from different sources. Continuous monitoring enables proactive issue detection, helping teams identify and address potential problems before they escalate. By monitoring key metrics such as response times, error rates, resource utilization, teams can optimize performance and enhance the overall user experience. Then next is security. So integrating security into the DevOps pipeline is essential for ensuring that applications are robust and resilient to threats. So DevOps has a superset called DevSecOps, where security takes higher priority. So DevSecOps principles emphasize shifting security left, meaning that security considerations are addressed early in the development process. Tools and practices such as static code analysis, vulnerability scanning, and automated security testing help identify and remediate security vulnerabilities early on. By making security a shared responsibility and incorporating security practices into early stage of the development life cycle, organizations can mitigate risk and build more secure software. I'll give an example. I was building an banking application where in the logs itself, by mistake, I was logging the customer information like its personal details, which is a very severe security threats. Now I had completed the development, the code is tested. Then after that, the information security team came to me and showed that these are the information you are leaking. So if we'll be using, if we'll give priority to security, this issue could have been detected very early. Okay. Next, the DevOps metrics and KPIs. We have started using DevOps, we have adopted DevOps practices. But how would we know that by using DevOps, we are doing better day by day? So that is where we have to measure ourselves for the practices and processes we are using. So DevOps metrics and key performance indicators provide valuable insights into the effectiveness of DevOps practices and processes. Metrics such as deployment frequency, the lead time, mean time to recover, help teams to measure their ability to deliver value quickly, respond to incidents efficiently. Tracking these metrics over time allows teams to identify trends, set performance targets, as well as continuously improve their DevOps practice. However, it is also essential to select metrics that align with organization goals and to avoid metrics that incentivize undesirable behavior such as sacrificing quality for speed. And case studies and success stories. So let's say I am going to start DevOps in my organization. From where I can take inspiration? I can take inspiration from organizations which have used DevOps and how they have transformed, as well as within the organizations. If another unit has started using DevOps practices, how they have performed. So those case studies could help us giving a good head start. So examining case studies and success stories of organizations that have successfully implemented DevOps can provide valuable insights and inspiration. These examples showcase how DevOps principles and practices have enabled organizations to accelerate delivery, improve quality, and increase customer satisfaction. By learning from these experience of others, teams can identify strategies and best practices that can apply to their own DevOps journey. It is not mandatory that we have to use the strategy we learned in the case studies. We have to use our own. It is also essential to understand the context and challenges faced by each organization and to adopt lessons learned to suit your own unique environment and objectives. While DevOps offers significant benefits, its adoption can also present challenges, particularly in organizations with entrenched silos and legacy systems. So silos are large towers in a farm which is isolated from the outside world. Cultural resistance to change is a very common barrier as DevOps requires collaboration, transparency, and willingness to embrace new ways of working. Legacy systems and processes may not easily align with DevOps principles, requiring careful planning and gradual modernization efforts. Integrating diverse tool chains and technologies can also pose challenge as interoperability and compatibility issues may arise. Overcoming these challenges require leadership support, investment in training and education, and a commitment to continuously improve and adapt. Next is continuous improvement and learning. So continuous improvement lies at the heart of DevOps. So we learn first and then we have proceed, and after that we are not learning. That is not going to happen with DevOps. So DevOps encourages regular retrospectives and postmortem, and that enables team to reflect on their processes and identify areas for enhancement. By implementing feedback loops, teams can iterate on their practice, refine their workflows, drive continuous learning and improvement across organizations. Next comes DevOps tools landscape. So what are the different tools we can use in DevOps. We knew few tools like uh, the CI/CD tools, ISE tools, then container and container orchestration tools. So the DevOps tools landscape is very vast and diverse, encompassing a wide range of categories such as version control, CI/CD, configuration management, monitoring, and more. Understanding the various tools available and their respective functionality is very crucial for building an effective DevOps toolchain tailored to the organization's specific needs and objectives. DevOps in the cloud. Cloud platforms play a pivotal role in enabling DevOps practices by providing scalable infrastructure and a plethora of services conducive to automation and collaboration. Leveraging cloud resources allows organizations to accelerate their DevOps initiatives, achieve greater flexibility, and scale their operations more efficiently. However, it is also important to carefully consider factors such as security, compliance, and cost optimization when adopting DevOps in the cloud. Future trends in DevOps. The future of DevOps holds exciting possibilities driven by emerging technologies and evolving industry trends. Artificial intelligence and machine learning are poised to revolutionize DevOps by automating decision-making processes, predicting and preventing failures, and optimizing resource allocation. Serverless architecture is gaining traction for its scalability and cost efficiency, while GitOps is emerging as a paradigm for managing infrastructure and deployment using Git workflows. Conclusion and next steps. So this is where we will look behind and understand what we have learned. So in conclusion, DevOps offers transformative approach to software development and operations, fostering collaboration, automation, and continuous improvement. We have explored implementing DevOps practices requires overcoming challenges, embracing a culture of learning, leveraging the right tools and technologies. I'll also encourage you guys to continue your journey into DevOps, exploring further resources, seeking mentorship, and applying these principles to drive innovation and success within your organization. So at the end, thank you. I am Aditya from Cloud Native Journey. Uh, I hope you have enjoyed this learning for 20 minutes. Thank you.